I like it simple. So what I'm looking for is not something more complicated, but something that's more easy. So I'm looking at, is there something such as a truth machine where you can detect lies from truths using simple button presses? Because as the advert says, this would be easy to operate and in fact amazingly simple. Whether it's indeed risk-free, entertaining and ethical, I'm not too sure. But still, in the last few years, I focused on reaction time-based lie detection. So can we discriminate lies from truths using simple button presses? There's clearly a reason for skepticism. There's been a meta-analysis that you all read, that you all know of, and there were 158 cues that were looked at. One of the cues Bella De Paulo looked at was response latency. And the effect size of response latency was 0.0 something. So that's not a big effect. So there's a problem. I'm not too discouraged by this finding because all these data were gathered in an interrogation context. So where you have an interviewing asking a question and you record how fast the interviewee responds to that question. Now for reaction time recording, that's not an ideal situation for response latencies. Response latencies can vary throughout. So in fact, in this situation, people didn't even have the instruction to answer as fast as possible. So the truth teller might decide to think about the question as well as the liar. So even if there would be differences in cognitive load, emotional arousal, it won't show in your data because the measurement is not precise enough. Typically also, the response latency is measured with a stopwatch instead of a precise computer. So there's all sorts of reasons, and most importantly, you only have a few observations, whereas typically for reaction times you need a lot of data. So what we need to do is tell our participants to press that button as fast as possible. Only in that condition you can get accurate response latency recording. So what we do in our experiments, we typically tell our participants to press a button, we tell them when to press it, and which button to press. So that's a very specific setup, a very specific computerized paradigm that presumably allows to detect deception. So here's one example how it might work. So in this particular study, we had participants preparing a mock espionage scenario. So they needed to go to this specific building, and inside that building they would meet a Confederate and exchange secret information. So we then caught them during the act, put them on this computerized lie detection test, and we said, whenever you get a number of pictures, if you see the picture of the crime location, clearly you deny to have anything to do with that, so you answer no, and you answer no as fast as possible. We record the response latencies, and they have to press within a second. Less than a second, 800 milliseconds to be precise. So then we compare that reaction time to other locations that have nothing to do with the crime. And we're interested in whether people are slower to respond to the crime location compared to the other locations. Now, if you were the subject, probably the first thing that comes to mind is, I can do this task with my eyes closed. You just close your eyes and press the no button the entire time. That would be an effective faking strategy. We thought about that. So there's a solution, which is you present also another location to which people have to press yes to. So we say, whenever you come across this location, you say yes. To all others, you say no. And this has two advantages, the inclusion of these target stimuli. First of all, you make sure that people have to open up their eyes, they look at all the pictures, and they have to process each picture in order to decide where to press yes and no to. The second advantage is it increases response conflict. So the question that pops up during this task is, do you recognize a stimulus? So now what happens is that for the target stimulus, clearly they say yes, but for the crime location, they have the urge to say yes, have to override that response in order to press the correct no response. And that further adds to the response latency increase that you see for the crime location compared to the others. So this results in this kind of graphs for this particular study. So people who have no idea what the crime location was, they responded similarly to the crime location and to the other locations. Whereas guilty suspects, they were significantly slower when lying than when telling the truth. Now you also see that effect in absolute terms is tiny. It's only 50 milliseconds. That's another reason why you can't see this in the typical interview situation. It's a fairly small reaction time increase in absolute terms, but that's why you need a lot of trials, a lot of observations, ever across them, and then you can pick up this reliably. And in this particular study, it resulted in an 86% hit rate. This is only one study, so you're probably not convinced by now. So what we decided to do is aggregate across a number of studies. In fact, Christina Sugotsky did this for her PhD. She looked at the paradigm that I just described, the concealed information test or memory detection test paradigm, as well as a number of other paradigms. And aggregated across these paradigms, she found a fairly large effect size. She also found that indeed you need to instruct participants to press that button as fast as possible. If you don't, you get lower effect sizes. But this meta-analysis also showed some limitations. First of all, there was publication bias. So we need your data. Please, if you have unpublished data on reaction time, send it to us because we want to include them in the meta-analysis. So the meta-analysis basically show that only the good RT results get into the literature. A second problem is that most of these studies are fairly small n's, so typically only 20 or so subjects in each study. And the third one is we want to look at what moderates the effect. We noticed that it was hopefully confounded. So it's typically between study comparison and all the moderators were confounded. So what we need is more primary research, preferably with larger n's, which will also allow you to publish the result irrespective of the outcome. So that's why we decided to go online with the reaction time tasks. And there's now, probably most of you know them, there's a number of platforms. Some of them have a few hundred, others have a few million people that are willing to engage into your study for only $50. So in this first study, what we did is we took the same paradigm but now applied it to a, let's say, false identity paradigm. So we first asked our participants, tell us a little bit who you are, where you're from, what's your age, what's your birthday, for instance, what's your country of origin. And then we said, now you have to pretend to be someone else. So in my case, I'm originally from Belgium. I would be said, okay, nice that we know you're from Belgium, but pretend to be from France. So this is how it works. I get France popped up on the screen, and I say, yes, this is my new identity, this is me. Then I get Norway, Sweden, Germany, UK, Netherlands, and so on. I always press no to them. And then I get Belgium. I want to say yes, but I have to press no, and that results in a reaction time increase. Again, you see that naive people didn't show any difference, and that people who are knowledgeable, they react more strongly to their own country. And I think with this web-based approach, we can really now quickly run a number of studies, better powered studies, and also look at some of the moderators that might have an effect. For instance, in this study, we looked at item saliency. How important is a certain item to you? And we reasoned that if something is very salient to you, it has a greater chance of popping up in that stream of stimuli that are presented with. So we asked people about their birthday and country of origin, and they said, yes, this is really important to me. We also asked them about their favorite color and food and animal, and they said that's less important. And you see that indeed in the data, you do get the effect for low salient stimuli, such as favorite food and animal, but the effect is much weaker. So we can learn a great deal about the reliability of the findings and also about possible moderators. And the best result we get so far is using the same paradigm, but what we learned in a cycle of a year of studies, we aggregated everything that we had and everything that we learned about possible moderators, such as item saliency, used only highly salient items, and we also used a great number of trials. There was a bit of a concern. We thought that maybe there might be a max of trials, because after a while, people might realize how the tasks work and might start engaging to faking. But that didn't seem to be a problem. So we got a decent, a fairly high area under the curve, and we also looked at individual accuracy. And we used, Jeff, yesterday you had a question about where to put the cutoff. I think this was a pretty good idea because you can use this kind of cutoff procedure for any lie detection tool. So what we do is we calculate effect size for any individual. So for each individual, we'll look at what the effect size is between the critical and the control stimuli, and we see if there is a small or a larger effect size. For that individual, we say, you're probably a liar. And that results, in this particular case, in about 9 out of 10 people caught. Now, Response latencies are clearly under voluntary control. So what you can do, of course, is try to fake the test. And we did some studies scraping the surface on how easy it is to fake this test. So the first thing we did is pay people. We just said, you do this test, same test that I showed you over and over again now, but you get more money if you're able to beat it. We didn't get any effective motivation in 2 studies, each with a few hundred participants. And what might be happening is that with the money, people are incentivized to engage into faking and effectively fake, but at the same time, the motivation might also increase the saliency. So those 2 effects might cancel out each other. Then we ran a number of lab studies trying to see what maybe people didn't just have any clue on how to fake the test. So we ran a number of lab studies in which we instructed people how to fake the test. What people often try to do is try the reaction time on their critical items down. That's very hard. The easiest way to beat the test is, of course, increase your reaction time on the control items. So we told people to do that and didn't get any effect of faking. But that's, of course, a null finding. So we decided to run a big online study with more than 1,000 people, instructing people with faking strategies that have been suggested in literature. And again, this was, well, the paradigm doesn't matter. This were the data. Again, the fakers, even though they had very specific information on how to beat a test, they weren't able to do so. I wouldn't claim that this test is unfakeable. Clearly, any lie detection test is fakeable. But it's at least not as easy as you might presume for a reaction time-based lie detection test. And one of the reasons I think it has to do with the speed of the task. You present each stimulus about 1 second after each other, and you only have less than a second to respond to each stimulus. So that makes it very hard to implement an effective faking strategy. So I think so far what we learned using this web-based approach is that, yes, we can run studies now on the web as reliably and validly as we do in the lab. And it gives us the advantage of having a more diverse sample, so we don't have only the 19-year-old female, slightly neurotic students, but we have people from all over the world. And so that we didn't actually look at the data yet, but we are planning also, of course, to look at cross-cultural differences. At the same time, we were very worried about having very noisy data. And I think the way we tackled it is have first very crystal clear instructions and always check whether people understand the instructions. Second of all is we have a number of practice blocks before people start with the actual test that gives them first at a very slow pace, easy to understanding, now I have to press button, yes, now I have to press, and they get into the task, always get difficult, and then only if they meet certain thresholds, they can start with the actual deception task. And the third is also that we throw away a lot of people. So we throw away about a quarter of our data. Maybe we don't even need to, but we are very strict because we say if you have too many errors, if you respond too fast or too slow, and a number of other criteria, we throw away the data and we only look at the people who meet our quality criteria. Now, I think from technological advancements, so one is indeed trying to understand when it works, trying to improve this test. For me, an important lesson has been also is trying to understand from our mistakes, so when it doesn't work. And here's an example. So for this TV show by Marcel van Tilt, famous Belgian, I was asked to demonstrate this technology. And so they had this show where they had 4 couples, and the man and the woman would engage into a different night out. It's a very ecologically valid study because the man, they went out for a boxing match with a transvestite, and the woman, they went out and eat a red banana with a dwarf. And the question to me was the couples could interview each other, and they needed to find out where they've been and what they've done. And they weren't able to do so. Of course, they also reached the 54% accuracy. And then there was me with my lie detection test, and I needed to identify whom they were with. So this is the way I set up the test. I present them with these weird creatures. And of course, I wanted to see, I thought, well, people who were with a dwarf that evening, they would respond to the dwarf, clearly. I had no effect, nothing. So that puzzled me. And I said, I do everything the way I always do it, so this test has a huge effect size. It must work. And then I realized there was this one tiny thing that I did different than others, is I presented it block-wise. So first I presented all the faces of people that they could have encountered, then all the locations, then all the times, and so on. And apparently that slight change was effectively destroying my test. So it's actually two different protocols that have been used in literature just interchangeably, assuming that they both are equally effective. But we found out that that's not the case. So what works here is that, where's my, yeah. So people needed to say yes to this guy and no to all the others, and I was of course interested in, is this response latency slower than to the others? But if you only get the faces, it's very easy to do this task you just say yes to the black guy, no to all the others, and you don't need to process anymore whether this is a tattooed guy or a mime or a transvestite or a dwarf. So what you need to do is mingle all the stimuli so they have a fully randomized, like here, you show the tattooed guy, then the red banana, then the box ring, you intermingle all the stimuli, and that makes it much harder to do the task and much harder to beat it. So the point I wanted to make is, this was just, we piloted in a few subjects, we saw it didn't work, and normally would have stopped there and would just go back to what I used to do. Now with this online version, we can quickly just run a study to see, is this really what's happening? And we found out that it does make a big difference. So, my conclusion is, there may be such a thing as a truth machine, in the sense that yes, you can detect lies from truth using response latencies, and we can do this also online. Thank you.